and looks at problem solving. So it gives a connection as to where you could use a rational equation to solve a word problem or to solve a situation. When you are trying to solve problems, the kind of the flow chart or the methods, the steps that you would take, the first thing that you need to be able to do is you need to be able to understand what the problem is asking. So it might mean reading the problem more than once. It might mean highlighting keywords so that you can understand exactly what the problem is, what the question is asking, so that you can then form your equation. The next step would be choosing a variable to represent an unknown quantity. And usually your unknown quantity is the quantity that's being asked for. So the question might say two numbers are this, this, and this. This is the relationship between the two numbers. What is the smaller number? So then I could let x be the smaller number. Once I do that, then usually I have something else that I could write in terms of the smaller number. The larger number is half or double, 2 times plus 3 more of the smaller, or something to show that relationship between the two. Once you have your variables and your quantities, you can then use it to write an algebraic equation. In our instances, these are going to be rational equations, so I should have a variable in the denominator spot. Then you'll solve the equation using the methods we worked on in the last 2 lessons, and then go back and see whether or not your solution actually solves the problem. Okay? So the first type of problem we're going to look at is our distance, speed, and time graphs, the ones that I, in grade 9, called the STD graphs. You guys have done physics for 2 years. Distance over speed and time with a nice triangle. If I cover up t, it tells me I take distance divided by time. Cover up d, speed times time, etc. So competing in an endurance race, Shannon has to bicycle for 120 kilometers and then swims for 12 kilometers. Her average cycling speed is 8 times faster than her average swimming speed, and Shannon took 9 hours to complete the race. If her average swimming speed is expressed in s kilometers per hour, let's use that information to fill in the rest of the chart. So what other pieces can I put into the chart?
Well, you know both the distances.
Okay, so what do I put for the cycle distance?
120 kilometers.
And swimming?
12.
Okay. What else do I know?
You know that her cycling speed was 8 times faster than her swimming speed.
So then how would I express that?
S8.
S8 or 8S?
8S, yeah.
Okay. And how do I relate distance and speed to time? So if I know the distance and the speed, how do I find the time it takes? Distance divided by speed. So the time column would be 120 divided by 8s and 12 divided by s. What else do I know?
Took her 9 hours to complete her.
So that means the time to cycle plus the time to swim would be equal to 9 hours. That becomes our equation. 120 over 8s plus 12 over s would be equal to 9 hours. And then how would we solve this? What's our steps for solving? Multiply everything by 8s to get rid of that denominator. So when I multiply 120 over 8s by 8s, they're going to cancel out. I'll be left with 120. And when I multiply 8s by 12 over s, what cancels? The s's, which leaves me with 8 times 12. And then 9 times 8s. 8 times 12?
96.
96. And what's 96 plus 120?
216.
So then what does S equal? How much? 3? So what does 3 represent? Kilometers per hour of what?
That would be for swimming speeds.
So swimming speed is 3 kilometers per hour. What would her cycling speed have been? 24 kilometers per hour. So if you look at the next question is also going to be a speed, distance, and time problem. So St. Andre Students' Council is traveling from Knoxton to Harborville for the Student Council National Conference. From the travel budget allowed for the trip, they have 2 options. They can leave tonight by bus, or they can save 3 hours by leaving tomorrow morning and use the express train, which travels 25 kilometers an hour faster than the bus. If the distance between the 2 towns is 1,500 kilometers, determine how long it would take if I took the express train. So with these problems, your best bet is to start off with a chart. Organize your speed, your distance, and your time using a chart. And in my chart, what I will have is my 2 modes of transportation. I can take the bus, and I can take the train. And then I'm going to have my distance, my speed, and my time. So distance, speed, and time. So what information do I know?
You know the distance is 1,500 kilometers.
So the bus has to travel 1,500, and so does the train. Okay? Do I know the speed of either mode? Do I know how fast the train travels or the bus?
Well, you can let one of them be X, can you? And then the train would be X plus 25. This is 25 kilometers.
Okay, so I let the speed of the bus
Or it could be S.
would be S kilometers per hour, okay? And then the train would be S plus 25. And then I have the time. Well, if I have 2 columns, I can find the third by using the relationship between distance, speed, and time. So in this case, again, it would be division. 1,500 divided by S, and then 1,500 divided by S plus 25. Now, what do I know about the time it takes the bus and the time that it takes the train?
The bus takes 3 hours longer.
The bus takes 3 hours longer because I can save 3 hours if I have the train. So the bus time minus the train time would be 3 hours. That's the important part, is realizing which time is going to be greater. Is it going to take longer by bus or by train? Because I'm finding the difference between these two, order is important. So now I can put together my equation. I have the bus, which is 1,500 divided by S, minus the train, which is 1,500 divided by S plus 25, equals 3. So then how would I solve this? So multiply by what, Rachel?
S plus 25.
And S as well. It has to be the common denominator of both of these. This is a factor, and this is a factor.
Why did we do that on this question but not the other question?
Because in the other
right,
question,
this
they're
is-
monomials. This is a binomial in here, right? So the S is being added to 25. So then when I go to do my multiplying, the S's will cancel out, and I'll be left with 1,500 times S plus 25. Then the S plus 25s will cancel out, and I'll have 1,500 times S. And then I will have 3S times S plus 25. And then I no longer have denominators to work with or worry about. So if I multiply through to remove my brackets, 1,500S plus, what is 1,500 times 25?
47,500.
Okay. And then I have 3S, oh, sorry, I forgot about the 1,500S. Plus 1,500S equals 3S squared plus 75S. So I'm going to end up with a quadratic because I have this S squared and I can't cancel it out. So my next step would be to move everything over to the other side. So I have 3,000S, which is going to become negative. So what is 75S minus 3,000S? Oh, wait a minute. I made a mistake here. Not plus 1,500S, what is it? Minus. Somebody watching this right now is just like freaking out for the last 2 minutes. It's minus 1,500S. So the 1,500S's will cancel out, which will leave me with 75S on with the 3S squared. And then if I bring the 37,500 to the other side, it will become negative. And does it matter if I put the 0 on this side of the equation or if I put the 0 over here? It doesn't matter. I go to factor this. When I'm factoring quadratics or when I'm factoring any polynomial, my first step is to see if I can remove a GCF. Are these three numbers divisible by 3?
Yep.
And what do I get when I divide them all by 3? 75 divided by 3? And 37,500 divided by 3. So now I need to see if I can figure out two numbers that when I multiply them together, I get negative 12,500, and when I add them together, I get 25. Which one's positive and which one's negative?
S minus 100. S plus 100.
So the 125 has to be positive in order to get that positive 25. So what does S have to equal in order to make this equation true? What values could S be? Or what does S represent in my question? The speed. So are both of these answers valid? Can't have negative speed. So I reject that one. So now that means that the speed of the bus is 100 kilometers per hour and the speed of the train is 125 kilometers per hour. Have I answered the question? What does the question ask me to calculate?
How long it would take to travel by train?
Have I figured that out yet? So how do I figure out how long it'll take to travel by train? 1,500 divided by, so 125. How long? 12 hours? So without doing any calculations, how long would it take by bus? 15 hours, because it's just a little bit more. So your questions, 1, 4, and 7